The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
All right, wonderful. Now let's take a look at some examples. Example, static equilibrium, force of tension 1. What is the force of tension on the rope if Janus's weight is 686 newtons? Well, in this problem right here, we know that Janus is at rest, right? He's not moving in either direction, right? Not in the horizontal or the vertical. So we know he's at rest, so this is going to be a static equilibrium problem. And knowing that it's going to be a static equilibrium problem, we from that we know that it's also, we're going to have balanced forces as well, right? Because if we look here now at our free body diagram, we're going to have two forces that we're working with. We're going to have the force of tension on the rope, and we're also going to have the force of gravity, also Janus's weight in this scenario, right? Thus, because we have two vertical forces here, our force net, right, is just going to be the tension, is just going to be the tension plus force of gravity, right? And again, we said for balanced forces, that's going to be 0, right? Thus, tension is just going to be your force of gravity, or otherwise known as J's weight, right? And that's going to be 686 newtons as it was given to us. And there we are. Wonderful. So now let's move on and do something a little bit more challenging. Okay, we have three different scenarios here: scenario A, scenario B, scenario C. Scenario A, Janus is hanging from a single rope, right? From scenario B, he's hanging from two ropes, and scenario C, they're angled, the ropes, right? Wonderful. The vector sum of all forces in scenario A, B, and C is going to be what? Well, the vector sum in all forces, because Janus is going to be at rest, right? We know that is, and the forces are going to be balanced. The vector sum is going to be 0. Wonderful. Now, how about the second question, right? In scenario A, the magnitude of the tension in the rope, so the magnitude of the tension in this rope is going to be what to Janus's weight? Well, that's just going to be equal, right, to Janus's weight. Now, let's move on to the next question. In scenario B, the magnitude of the tension in the rope is what of Janus's weight? Well, in scenario B, it's actually going to be half of Janus's weight. And we know that because force net, right, is just going to be 2T for two forces of tension, right, plus the force of gravity, which is also Janus's weight, which is equal to 0, right? And then tension is just going to be half of Janus's weight. Wonderful. Now, what about our last question here, right? It says, in scenario C, the sum of the two vertical components from the force of tension in the two ropes is blank to Janus's weight. Well, the sum of the two vertical components is going to be equal to Janus's weight. Now, let's actually expand on number 4 here, and we'll do so on the next slide. Great. So example, force of tension here. Perfect. Perfect. Okay. Which rope has greater tension? Tension in rope B is drawn to scale. Is it going to be rope A, rope B? Is the tension in rope A and B equal, or can it not be determined? Well, if this first of all is going to be a vector problem, so we can actually go ahead and solve for this problem, right, by breaking our force vector here into its components. And we'll do so first actually by